Welcome to this tutorial on broadcasting one-dimensional arrays to two-dimensional arrays in NumPy. Broadcasting is a powerful feature that allows you to perform operations between arrays of different shapes without writing explicit loops. In this video, you'll learn how to broadcast one-dimensional arrays to match two-dimensional array dimensions, making your code more efficient and readable. Broadcasting is NumPy's mechanism to perform operations on arrays of different shapes by automatically expanding smaller arrays to match larger ones. Think of it as NumPy intelligently stretching your arrays to compatible shapes. The key benefits are that it eliminates the need for explicit loops, making your code cleaner and more Pythonic. Additionally, broadcasting is memory efficient because it doesn't actually duplicate data in memory. It just behaves as if the data were repeated. NumPy follows three fundamental rules for broadcasting. Rule number 1, dimension alignment. Arrays are aligned from the rightmost dimension, meaning NumPy starts comparing shapes from the end moving backwards. Rule number 2, size compatibility. For broadcasting to work, dimensions must either be equal or one of them must be 1. Rule number 3, dimension expansion. When an array has fewer dimensions, missing dimensions are treated as having size 1 and are automatically added on the left side. There are 4 common scenarios when broadcasting one-dimensional arrays to two-dimensional arrays. Row broadcasting occurs when a one-dimensional array broadcasts across rows horizontally. Column broadcasting happens when a one-dimensional array broadcasts down columns vertically. Scalar broadcasting is when a single value broadcasts to the entire array. And element-wise operations are applied to matching dimensions, performing calculations on corresponding elements. Let's see row broadcasting in action. We have a two-dimensional array with shape 3x4, containing values from 1 to 12 arranged in 3 rows and 4 columns. We also have a one-dimensional array with shape 4, containing the values 10, 20, 30, and 40. When we add these arrays together, NumPy automatically broadcasts the one-dimensional array across all 3 rows. The one-dimensional array is conceptually repeated for each row, so the first column of every row gets 10 added, the second column gets 20 added, and so on. The result is a 3x4 array where each row has had the one-dimensional array added to it. Column broadcasting works differently. Starting with the same 3x4 two-dimensional array, we now have a one-dimensional array with values 100, 200, and 300. To broadcast this down columns, we need to reshape it from shape 3 to shape 3x1, creating a column vector. When we multiply the two-dimensional array by this column vector, NumPy broadcasts the column vector across all 4 columns. The first row gets multiplied by 100, the second row by 200, and the third row by 300. This produces a result where each row has been scaled by its corresponding value from the column vector. The newaxis attribute is a powerful tool for controlling broadcast behavior. Starting with a one-dimensional array containing 10, 20, and 30 with shape 3, we can add a new axis to create a column vector. By using array indexing with :numpy.newaxis, we transform the shape from 3 to 3x1. This added dimension enables column broadcasting. You can check the shape to confirm it's now 3x1. As an alternative, you can use none instead of newaxis. They work identically. This technique gives you explicit control over which dimension to add, making your broadcasting intentions clear. Let's review the key takeaways from this tutorial. First, broadcasting automatically aligns dimensions from right to left, comparing array shapes from the trailing dimensions. Second, one-dimensional arrays naturally broadcast across rows when their shapes match the number of columns in the two-dimensional array. Third, to achieve column broadcasting, use reshape or newaxis to convert your one-dimensional array into a column vector. Finally, broadcasting is memory efficient and eliminates explicit loops, making your NumPy code faster and more elegant. With these concepts mastered, you're ready to leverage broadcasting for efficient array operations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.